Hello, and this is a video about RSA encryption. And somewhere in this video there is a deliberate mathematical mistake. Let's see who can find it. But let's get to the actual meat of this RSA encryption. This is a diagram detailing what happens. So you request the public key, the server gives you the public key, and then your data is encrypted using the public key. Then your data is decrypted using the server's private key, and then you get your message, or your number, or whatever you want, or your funny GIF. But before we start, we have to talk about modular arithmetic. And this is a type of maths all to do with remainders. So, if you say something is y mod n, then you mean it is y more than a multiple of n. For example, 33 is 9 mod 12, because it's 9 more than a multiple of 12, namely 24. And, more crucially, 33 divided by 12 equals to remainder 9. And, say x is 1 mod 40, then it is 1 more than a multiple of 40. So it could be 41 or 481 or 4001. And the picture is a diagram saying that 12 mod 9 is 3, because 9 mod 9 is 0. 10 mod 9 is 1, because it's 1 more. 11 mod 9 is 2. And 12 mod 9 is 3, because it's 3 more than the multiple of 9, mainly 9. And 12 divided by 9 equals 1, with a remainder 3. So, what is RSA encryption? RSA is an algorithm. It is a type of asymmetric encryption. This means that there are two different keys to cipher and decipher the unreadable language to turn it back into English. One key is public, and everyone from Kim Jong-un to Mr. Bid can see your public key. One key is private, which only the recipient can know. So, you should not be like this person. This person's been posting his public key using to cipher it. However, he decides, very stupidly, to post his private key, meaning people all across the internet, from North Korean hackers to stupid people, can, in theory, get every single one of his encrypted messages using RSA encryption. So don't be like this guy from some webcomic I copyrighted from the internet. So, how do you make public keys? First of all, you choose two primes. So let's go with 5 and 11. Normally the primes are massive, over 5 digits long, but let's go for 5 and 11 because we don't want the numbers to be massive. Then you get the product, so 55. Then you calculate 5 minus 1 times 11 minus 1, or 4 times 10, or 40. And this is called a totient, and it's usually represented using a phi. Then you find a number which is co-prime to our totient, so 40. This number is something whose highest common factor with 40 is 1. So this could be something like 33, it could be something like 31, but I just went with 37. And E, which is the number that is co-prime, 37, is used to encrypt the messages. So, Alice's public key would be E, and it would turn into that language, this 6EB69570. And that's hexadecimal. That would normally be a number, but they often do hexadecimal because that's more unreadable than a big number. So how do you make private keys? You choose a number that, when multiplied by E, equals 1 mod the totient. Our totient is 40, and our E is 37, and 13 times 37 equals 12 times 40 plus 1. So 13 times 37 equals 481, equals 12 times 40 equals 480 plus 1. So our private key would be 13. So, RSA in action. Say we had the number in 11, usually represented as an M, and we wanted to encrypt it. So you would get C, or E to the N, or 11 to the 37. Already, using small numbers, you can see this as massive. Then you get C mod the product, 55, from way back, and you call it Z for now. And say Z is 34. And to decrypt it, you will raise Z to the power of the private key, or in this case, 34 to the 13. Call this Y. Get Y mod 55, and you'll get your original message back. However, normally the numbers will be 6 digits long and they will be really complex. So this is an ideal example, and already 34 to the 13 and 11 to the 37 are both massive numbers with over 20 digits. So, words to numbers. This may work for encrypting numbers and then converting them to the hexadecimals we saw with Alice and Bob, but what about words? So to get from words to numbers, and thus the unreadable hexadecimal, you will use a simple binary function. Say you had the word me, then you will change the E from the word me into a 5 in binary, so 00101, and change the M into a 13, 01101. And then you will put them together to get 01101, 00101, which equals 1 plus 4 plus 32 plus 128 plus 256 plus 512 equals 933. So if you were to get the number 933 using this, you would have to recognise it as the word me. Then you would split it into binary, separate the numbers into 5s, and then you would get your original word back. Normally they do from hexadecimal to binary, but that's very complicated. Oh, one more thing. Thanks for watching!